started. So welcome to our meeting today. Thank you so much for coming. Today we are going to be doing a workshop on technical interviews. So we know a couple weeks ago we had the Computer Science Career Fair, and so we're hoping, as you guys are getting interviews scheduled with different employers, that this will help prepare you for those interviews. Because normally in computer science internships, you will get or you will experience a technical interview at some point. So Nusha, if you could go to the next slide, please.
I'm sorry, for some reason, it's like, I am going to the next slide. Yeah,
No problem.
sorry
So
for
like
that.
I said, you're good. So like I said, we'll be covering technical interviews today. This will be led by Nushat. And then the next slide, please.
Oh my God, I don't know why it's doing like this. It's not going to the next slide, but okay. Yeah, sorry.
Okay, no problem. Okay, so just one announcement for today, actually. So next week, instead of our general meeting on Thursday evening, we will be going to a play on Ada Lovelace. So a local theater in Tucson called the Scoundrel and Scamp Theater reached out to us and invited us to this play because Ada Lovelace was a woman who pioneered computer programming in the early 1800s. And so this play is going to be about her and her story. So we think it's really fitting for our club to be there, and we really hope you guys want to come as well. So if you do, Aditi, our outreach coordinator, sent out an announcement about it. And if you're interested, go ahead and check that announcement out on Discord. You can also feel free to reach out to any of us in Discord or on our Instagram or email, and we're happy to give you that information as well. But it will be next Friday, the 25th at 7:30. And then the tickets are going to be $15 for student tickets. So we are going to have you Venmo our Wix account, and then we will buy the tickets all together just so we can make sure everyone can sit together. But yeah, we hope to see you there. And if you have any questions, again, feel free to reach out to us. And I'll let Nushat take over now.
Yeah, so hello everyone. I am again, I don't know what's happening with my computer, but it's doing okay. It's doing some weird things with the screen sharing, but okay. So this is the welcome to the technical interview workshop. I hope you're all doing great. So this is a brief overview of what today's workshop is going to entail. We are going to go over what to expect in technical interviews, how to prepare for them, and how to work through problems in the interviews and deal with quote unquote incorrect answers if you happen to come up with one, how to pick programming languages, which coding style to follow, and in the end, we'll go through some resources for the interview preparation. Also, we'll try to do a breakout room thing where we would practice mock interviewing, and we'll see how that goes. So thank God the slide changed. The problem was solved. But anyway, so this is a table which lists down the core data structures, algorithms, and concepts that show up in technical interviews again and again. This is by no means an exhaustive list, but it is a handy table to keep you on track when you are preparing for interviews. Since interviews don't have any definite syllabus, the preparation can get overwhelming and confusing at times with so much content out there. So if you follow the topics of this list and have a more or less good grasp on them, you can at least be somewhat confident going into the interview that you know the material or you prepared well. You can take a screenshot of the table if you want. Also, when you are preparing, make sure you understand how to use or implement these algorithms and data structures and know their space or time complexities wherever applicable. Don't worry if you don't know the terms space complexity or time complexity. You will learn and get very familiar with them eventually when you're preparing for the interviews. Just know that they are as important as coming up with solutions to the problems in interviews. Also, practicing the implementations of both data structures and algorithm is also a great idea because it helps you to learn the internals of each. So Before you even start preparing, you should know what to expect in technical interviews. So technical interviews are supposed to be hard. Don't lose hope if you find the question too hard at the first glance. Most of the time, interviewers don't even want you to come up with the solution quickly or immediately. They want to see how you struggle with a problem and what steps you take in coming up with a solution. So don't get discouraged if you struggle with one or more problems. That is totally normal and not bad. Chances are they're testing more than your technical expertise. It's also completely fine if the first solution you come up with is not efficient at all and is a simple brute force solution. You can always improve your algorithm as you communicate with your interviewer. Also, oftentimes interviewers want to see your thought process or approach to difficult questions. And that thought process that you take in the face of a difficult problem demonstrate your problem solving abilities. So definitely talk it out with the interviewer and keep communicating with them throughout the whole interview. So before the interview, when you are preparing for it, one good way to get ready for the interview would be to push yourself to develop a solution to the questions you're practicing with as little help as possible. Also, try writing the code by hand. Coding on a computer has certain advantages like syntax highlighting or code completion or quick debugging, etc. So if you have to get used to coding by hand and get faster at it, because more often than, so you have to get used to coding by hand and get faster at it because more often than not, you won't have an IDE to tell you about the small errors when writing code during an interview. Get used to testing your code by hand as well instead of just compiling and running it. Because again, chances are you won't have that option during an interview until maybe the very end. And after you finish writing your code, practice going through the code and testing the general base cases as well as edge or error cases with different outputs by hand, because that is also something you should be able to do in interviews. And lastly, there is no alternative to practicing. The more you practice, the better you'll get at solving problems. Make a list of all the errors that you were usually making in your preparation in your code, so you can keep them in mind during your interview. And again, don't be discouraged if your code doesn't run perfectly on the first try. Keep on trying to improving it by debugging it and testing it by hand. So what is the best way to walk through a problem during the interview? First and foremost, do more than just hearing the problem. Really listening carefully and asking clarifying questions is the key. If you are unsure or confused about any part of the problem, just ask. Interviewers can tell a lot by the questions you ask or how frequently you ask them. Asking questions is also important because oftentimes you can get a sense of the solutions by the questions that you ask. And asking questions also increases your understanding of the problem and the approach you are going to take. And this makes solving a problem that much easier. The second thing to do is come up with examples that will help you gain a deeper understanding about what the question is really asking you to do. Try to get test cases by yourself that are specific, as in with real numbers or strings, and that are sufficiently large, and which are also not a special case, but a general case of the problem. And run these examples once through interviewers to make sure one last time before starting the problem that you really understand what is being asked in the question. The third thing is stating a brute force solution. The first naive solution that comes to your head at the very first try, state that to your interviewer. This helps you to get a better understanding of the problem in general. Some people don't state the brute force solution because they think it's too obvious or terrible, but you don't want the interviewers to think you are struggling to say an easy solution. If anything, stating the brute force solution first gives you a place to start and gives you the scope to improve the solution to reach an optimal one that can show the interviewer your thought process, which is usually a good thing. You want the interviewer to see your thought process. So once you have a brute force approach, the fourth thing is working to optimize it. Think about how you can leverage the information the interviewer has told you so far. Look for any unused information like sorted versus unsorted that you can use to your advantage to make the algorithm more efficient. Most of the time, every bit of information that the interviewer gives you is for a reason. Again, ask questions. Oftentimes, you can demonstrate your fundamental technical knowledge without directly or specifically answering the question in hand. So if you try to ask questions while optimizing it, you will find new things about the problems that will help you optimize the solution and making it more efficient. Also, after coming up with the algorithm, don't just dive into coding. Take a minute to solidify your understanding of the solution and walk your interviewer through your solution or your algorithm to ask if they have any feedback or suggestions for improvement. It also helps you get a feel for the structure of the code. And also, if say your algorithm that you came up with was going into a completely wrong direction, if you walk your interviewer through before you try to implement it, they can direct you in a correct way. So that will help. Also, keep talking while you implement because the interviewer wants to hear how you approach the problem. You only have a short amount of code to short amount of time to demonstrate that you are a developer, also a short amount of code too. So explain why you're using the data structure you're using, why the implementation that you're doing makes sense for this problem, and so on. Explain what you're doing because again, the interviewer wants to see your thought process and your skill in development. And after you finish writing your code, the last part is testing. So in the real world, code is never submitted without testing. So think about it like being in a code review. You can argue or prove your solution is correct logically to your interviewer, or you can again walk through each line of code and explain what is it doing. Like you walk through your algorithm before, but now walk through your code and explain why the code is implementing your algorithm and where it is doing it. And if you find bugs, analyze why the bugs occurred and attempt to fix them. Does anyone have any questions at this point? Because I talked a lot, I know. This slide is like really big.
How long during the interview question, when you're given a question, how long should you take the time to ask the clarifying questions?
Yeah, usually the clarifying questions, you should ask questions till you understand the problem completely. Like there's no given amount of time, but like don't keep asking the questions, more and more questions, just to like show the interviewer that you are like your thought process or anything. Just try asking questions till you completely understand the problem and you know what you are trying to implement or what the problem is asking. Generally, asking 1 or 2 or maybe 3 questions is fine. You should ask them, but then maybe you should move on to the drawing an example and maybe coming up with the algorithm part. Okay, if no one has any more questions, I will move to the next slide. Oh my God, it's okay. My computer is again. Okay. So after you are done with your first round of solution, you should try to optimize it, because oftentimes the first solution that you come up with is not optimal or efficient at all. It's more often than not is the naive solution, is the brute force solution, and you should work on trying to optimize it because like interviewers want the efficient solution and want to know if you can make your code efficient and if you have knowledge about space or time complexity. So the question is now, how do you optimize the naive solution you came up with? The first strategy is looking for BUD. The 3 most common things an algorithm or solution can waste time doing is first, bottleneck. Bottleneck is the part of your algorithm that slows down the overall runtime. One example of that would be, say, a chunk of code or chunk of work that is being done repeatedly, or a one-time code or one-time work that is so big that is slowing down your entire part of algorithm. So you would want to change those parts of code and try to come up with something more efficient that does the same thing. The second and third part of BUD is duplicated and unnecessary work. An example of that would be, say, performing an operation repeatedly when it only needs to be calculated once. A good way to avoid this is by thinking about pre-computing information and not doing the duplicated work and trying to come up with something that finishes the work at one time. Sometimes you don't even notice that you are duplicating work again and again that can be done very easily. So trying to notice those things in your code you have to do this in this part. The second strategy of optimizing is trying to work through the solution intuitively on a real example. For example, if you work through linear searching versus binary searching on an array by yourself, you understand intuitively that binary search is a better algorithm. So intuition can sometimes lead to a decent algorithm or solution. Don't worry if you don't know the binary search or linear search. That was just an example, but yeah, things like that. Sometimes to work on a real solution to see if another algorithm is working better. The third strategy is to simplify or tweak a certain constraints, such as the data type in the problem, and try to solve the simplified or tweaked version of the problem. After doing that, you can apply it on the actual problem. The fourth strategy is base case and build. This strategy is usually applicable to problems that leads to natural recursive algorithms. So in this strategy, you start with a base case and then build from there. You use the simple base case to handle more complex cases. Again, this is a good strategy for solutions that work better with recursive algorithms. To understand that you have to practice with recursive algorithm a lot to get a sense of this optimization. But it is a good algorithm. This is a good strategy for those cases. The fifth strategy is iterating through a list of data structure that you know in your head quickly and apply each one of them roughly to the problem to get a sense if you can make the algorithm more efficient with them. So the more problems you do, the more developed your instincts will be on which data structures to apply, because most of the time, using a wrong data structure can really slow down your problem. So the more data structure you practice with and you learn to apply with, the more easily you can optimize your solution and get a better understanding of what data structure to use where. So there's a fear. How do you handle incorrect answers? There's a fear in the mind of the interviewees that what to do if they come up with completely incorrect solutions in interviews. Responses to interview questions, for the most part, should not be thought of as correct or incorrect. It's more about how optimal your solution is, how long it took you to get there, how much help was needed, and how clean your code is. Also, the time your performance is evaluated in comparison to other candidates. And even if you couldn't reach the solution to the problem in the designated time, there is no need to panic. Many of the questions are too difficult to expect an immediate solution. The interviewer probably expected that none of the interviewees are going to reach the solution and is going to select the candidates based on how they reacted and work through an insanely difficult problem. So instead of panicking or getting frustrated or scared, discuss your ways of thinking with the interviewer, how you think the problem should be approached, what are the pros and cons of each approach, and try to build your solution and go from there, and you should be fine. Coming up with incorrect answers should be the list of your concerns. You should start building from whatever you know. So at this point, where I want to do a breakout room activities. This is a very famous problem. This is a lead code problem that almost everyone who prepares for technical interviews goes through. I'll copy and paste the problem in the chat, and in the breakout room, try to come up with the answer to the problems while discussing it with your peer. like try to make it like a mock interview, while one of you should like try to come up with a problem, and other maybe no, that would be the one of, if that wouldn't work if one of them doesn't know, maybe two of you try to discuss the problem and try to come up with first a nice solution and try to optimize it with the strategies, and see if you can do that. I'll paste the problem in the chat, and can Beza, if Beza create the breakout rooms, and you can go through the problem.
Okay, I'm pausing the recording and then
Yeah.
go into the breakout rooms and then come back.
Deshan. Okay, can everyone see my screen?
Yep, we can see your screen.
Okay, thanks, Beza. So so sorry for the delay. I wasn't anyway. So how do you decide which language you use in your interview? Some companies look for specific language proficiency, and so you have to code in that language. But if there aren't any constraints from the company on the language, pick the language that you are most comfortable with. Consider picking a language that is widely known, readable, has less verbose, and language requirements. For example, consider how verbose Java is compared to Python. So if you are not amazingly comfortable with the syntax of Java, maybe it would be a better choice to pick Python. Coding by hand, so you know each language's advantages and disadvantages, and you can choose wisely. Also, students are often concerned if the code they come up with is a quote unquote good code or not, or how to even write good code. So broadly, good code is a piece of code that is correct, efficient, simple, readable, and maintainable. But it is asking for a lot from an interview to fulfill so many requirements for a solution that they have extremely limited time to come up with. So focus on getting your solution to be correct, efficient, and readable first. So correct is a code that operates correctly on all expected and unexpected inputs. Efficiency is the code should operate as efficiently as possible in terms of both time and space. And readable is a different developer should be able to read your code and understand what it does and how it does it. So make sure first and foremost your code operates correctly on all expected and unexpected inputs. It does it efficiently, and it is readable clearly to your interviewer so that they can take a look at your code and instantly understand what you're trying to do. And maybe emphasis on simple being your code to make your code simple too, but I don't think making it maintainable is that much of an emphasis in technical interviews. So it is very important not to give up in the middle of the interview. Sometimes the question can feel too hard, and when you get stuck, it is completely understandable if you start feeling like you are not going to get this job or internship, and this is going very bad, or what is even the point of these things like that. In times of those cases, though, instead of getting discouraged and losing hope or letting your mind derail negatively, focus and ask questions. Directly ask for help or hints from your interviewer, and try to get through the problem as best as you can. Treat the interview as a simple conversation at this point. Again, interviewers are testing way more things than your technical ability. So it can be very overwhelming and stressful. So it is normal to be stressed during technical interviews, and to handle the stress, it is important to show excitement when given a tough problem. If you show excitement and create enthusiasm in your mind and take the problem as a challenge instead of a hurdle, it would help immensely to alleviate and soothe your nerves and anxiety. If you are thinking clearly and not overly nervous, you will be surprised by the solution your brain will be able to come up with. So you finished your interview, what to do now. Consider creating a table or a list of questions you are asked in the interview, and write down problems you faced while solving them, and also the solution that worked well. Keeping track of things that didn't work well and that worked well like this will be valuable references to get back to before your future interviews. I have a table structure here that might be useful for doing that, but honestly, you should follow whatever is intuitive to you while making the reference sheet. Later, when you're preparing for an interview again, go through these problems in your reference sheet once more and attempt to solve them without time constraints. Following the how to prepare guidelines, try to gauge your improvement from before. Consider how you should change your strategy while interviewing if you find yourself making the same mistakes again and again. Also, don't forget to email a thank you note to your interviewer after the interview. It is a good practice and helps leaving a positive impression on the interviewer. So here are some resources to help you get started and prepared for technical interviews. Cracking the Coding Interview is a very popular book for technical interview preparation. If you learn best by reading and practicing from a book, then this is a great resource that many people vouch for. You can also use sites like HackerRank or LeetCode to hone your problem-solving skills. I think most people preparing for technical interviews take this route because in these sites, not only you can check if your solution is correct or not, but they will give you the runtime of your code, which will make you understand if the algorithm you came up with was efficient or not. YouTube is actually a great resource too. You can find so many great explanation videos and advice on how to tackle common interview questions and problems, starting from how to start thinking about them to how to solve them. So practicing and studying with your peers and interviewing each other is also a good way for preparing and getting over the fear of interviewing. It also gets you in the habit of communicating during the interviews as well, which is super important. Also, if you think you need mock interviews, the CS Career Coordinator, Arthur Jordan, is a great resource for that. You can arrange a meeting with him for doing mock interviews, as well as getting help in preparing for all the other parts of interviewing as well. Also, I hope the breakout room session was productive. I think the two participants that I talked with, they came up with their solutions for they came up with solutions separately. So I hope you'll keep working on them. Also, I think that was it for the technical interview workshop. If anyone has any questions, feel free to ask and I'll be happy to answer. But other than that, thank you so much for sticking around and listening to the presentation. And I hope you all have a great night. Thank you.